All right, grade 12s, can you guys all hear me? Okay, unfortunately, I don't have a lapel microphone, so if at any point you can't hear my voice, please let me know, and then I will try to maneuver this device so that you can hear me, okay? For those of you that do not know me, my name is Natasha Barton. I am a teacher at Tucksport High School, in my opinion, the best high school in the world, but I know you all have different opinions. Thank you guys for being here. Thank you for giving me the opportunity to be here and assist you guys. I hope that you'll all learn something. We all are very, very different. We're coming from different backgrounds. We're not all from Gauteng. And it's going to be difficult for me to meet you all where you need me to, but I'm going to try my absolute best, okay? So guys, the goal today is not to necessarily work through questions, but to instead look at the approach and see where you guys are going wrong. Year after year, we find matrics writing exam papers, and they always make exactly the same mistakes. So some of you just want to pass. It's based on whatever your goals may be. Maybe you want to go into the sciences. Maybe you are taking science because your parents forced you to, and that is actually quite common. Okay, you can't always choose, or let's put it this way. Sometimes you can choose the path you walk, but when you can't, you can always choose how you walk it. Okay, so today we're going to do our best to walk this path as best we can, okay? And even if you didn't choose to take physical science, we're just going to do our best because it's going to build our characters, even if we don't enjoy the science, all right? So I'm going to start off with a few very general exam tips, some which you will know, some which you maybe don't. The first thing I want to speak about is how long you guys study for. And I say here, study for 3 hours. What I mean by that is, I don't know why, I don't know how, but we tend to say you guys should study in short periods and take short breaks in between and so on and so forth. So some people tend to study for 1 hour and then they take a 15-minute break. Or you study for 30 minutes and then you check your phone or something of that sort. But what I have found, grade 12s, is when you guys are in an exam venue, writing a 3-hour paper, you battle. Because you don't have the ability to concentrate for so long because you are not training the way you're going to play on the day of the game, okay? You need to practice so that you can play as you need to, okay, on the day of the match. So what is the match here? The match is you're going to write a 3-hour science paper. So what you want to do is you want to try and study for 3 hours. And yes, you're going to drift off from time to time. Your brain cannot possibly focus for so long, but you're going to get better at it and better at it because your goal is not just to pass grade 12. You guys want to go to university, and guess what? You're going to have to study some more. So we need to build the ability to study, and often for very long periods of time. Okay, the next thing I want to speak about, which is a little bit of a tricky thing to talk about, is music. So I know a lot of learners nowadays, when I was young, we didn't really have earphones and all of that, so music was not such a big thing. But I know that a lot of you study while listening to music. And I'm not here to say that I'm against it. I look at the science and I see what the science says. So my advice is, if you're someone who needs to listen to music while you study, normally, or what the science suggests is, you should listen to music that does not contain any words or lyrics. So you're looking for background noise, okay? I'm a piano, if we're talking about classical music, meditation music, that sort of a thing, okay? But if you're listening to Beyonce, Beyonce's voice is distracting you, okay? And what is happening is, your study session, which is actually not very enjoyable, becomes so fun that when you get into your exam, and you have to sit in a very quiet venue without Beyonce's voice in the background, you struggle. Suddenly you are so anxious because you do not know how to cope and how to write a physics paper without music playing in the background. So personally, I don't study with any music or anything of that sort. If I do, I listen to white noise. White noise is that shh that you hear if you go to the wrong channel on a TV. I don't know if it's still like that. But I normally use white noise if I need something in the background or something to block out the noise. But just remember, grade 12s, on the day of your exam, there's not going to be any music. So you want to create an environment that is similar to the exam so that you can actually function on the day of your paper. Okay, and that's not just for science, it's for any paper. Then, time. When you're practicing past papers, what often happens is you guys study in a relaxed environment. You know, we have reward systems. I have a few sweets, and after I go through a paragraph, I'm going to give myself a sweet and be happy and that sort of a thing. But the environment is very relaxed, and based on that, you take a lot of time to complete what would take very little time in an exam. So what I'm suggesting over here when I say time yourself, especially when practicing past papers, is actually have a timer or set a timer that will go off so that you can see if you're working fast enough. If you ever run out of time, especially when you're writing a physical science or math exam, then maybe it's because while you are studying, you are just too relaxed. So maybe start to time yourself while you do past papers. If you are writing a CAPS paper, so government paper, then it is 150 marks for 180 minutes, which means you have 1 minute and 12 seconds per mark. Okay, and based on this, you will be able to work out how much time you can actually spend on each type of question. Then guys, when you mark, every single year without fail, whether it be my grade 10s, 11s, or grade 12s. After they write a paper, they run to me and they say, ma'am, or after they get their marks actually, they run to me and they say, ma'am, but I studied so hard and I did that 2012 paper and I did so well, I even got a distinction. How is it possible that I'm getting 40% now? And the reason is because you guys love yourselves. And so when you are marking, you mark leniently. And when you see, maybe I can get the mark, you give yourself the mark, and when you tally it all up, suddenly you get this beautiful mark. And then when you actually write the paper and get it back, the mark is not so good. So please guys, when you are practicing past papers, whether they be IB or CAPS, please make sure that you mark yourself very, very strictly. Okay. Also, mark as soon as possible. So guys, let's say that you are practicing a whole lot of Newton's laws questions. Right? Let's say you have an exam pack and it's filled with Newton's laws. So you start off with the first question, you finish it off, you go on to the next one, you finish it off, and you spend 3-4 hours doing Newton's laws questions. Then you get so tired that you don't mark immediately. So you take a break, you go watch some TV, you do whatever you guys do, and then you come back and you mark. The problem is your brain develops habits, and it learns the things that you do the most. So if you consistently make the same mistake over and over and over and over again without correcting it, guess what's going to happen? Even though you mark after, 4 hours later, your brain is going to remember the mistake. And so when you get into your exam, you're going to make exactly the same mistake. So my suggestion is, don't finish a whole past paper, especially not, well, way before the exam when you're still preparing. Don't finish a whole past paper. Do question 1, then mark it. See where you are going wrong immediately so you can correct those mistakes and you never ever make them again. Okay. Then guys, cell phones, they distract me, so I'm sure they distract you. It's very, very difficult, okay? I think sometimes we become so anxious that we need our cell phones and we check them every other minute just to calm ourselves down, okay? But what I have found is we love color. Color is a beautiful thing. So what I do when I need to focus is I put my phone on grayscale. So you guys can see the comparison on the screen. If you go onto Instagram when your phone is set to grayscale, it's not a nice environment. If you're on TikTok and it's set to grayscale, you're not going to enjoy it. So if you can't get rid of your phone because you need it close by, maybe there's an emergency, maybe someone needs to contact you, maybe you're using your cell phone to time yourself as I suggested earlier. Set it to grayscale so that your brain doesn't feed off of the color on your cell phone. So on a Samsung device or an Android device, you go to your accessibility settings, and over there you'll be able to set your cell phone to grayscale. Okay. Next, guys, I know you are very, very nervous about your exams and you want to get everything in and you have very, very big goals, but you need to sleep. You really, really, really need to sleep the day before your exam. When you are studying, it is like going to your cupboard and taking out all of the files and taking all the pages out of the files and putting them all over on your desk. When you sleep, what your brain does is it takes the individual sheets of paper and files them and organizes them so that you know, oh, this is Newton's laws. If I get into a Newton's laws question tomorrow, this is the part of my brain I must go to. Oh, this is momentum and impulse. This is where I go to. If you do not sleep before you write your exams, what's going to happen is you're going to blank out. It happens often. We've all experienced it once or twice in our lives. It's normally because we haven't studied enough or because you haven't gotten enough sleep. You need to sleep so that your brain can organize all of the information that you've placed into it. Okay, then guys, the internet is a wonderful thing. I know you guys make use of a lot of videos on the internet. Mr. VG, I'm sure, has told you guys about the juniortiki.online platform. I know a lot of you for science make use of Kevin Math and Mr. Mnungisi Nkosi. Yes, am I right? Ne? Yes. Guys, when you watch those videos, please do not watch them passively. Don't sit there and think that it's going to go into your brain. We learn through our senses. So when you write, when you summarize, when you teach your dolls, and I know it sounds strange, but I had a friend at school who used to get 90% by teaching her dolls. Okay, that's what she used to do. When we engage our senses, we tend to learn better and retain the information longer. So please don't watch any videos passively. You must set goals, guys. Otherwise, you're not going to know where you're going. I don't think I need to say anything more on that. And you have to plan. Okay. So today we're going to focus on the paper 1 exam. If you guys have any questions while I'm talking, please feel free to put up your hand and ask. I don't think I'm too scary, so please do ask. But I'm now going to speak mostly about the paper 1 exam. Okay, it is your government paper, so I'm very sorry if you're an IB learner, but it's similar. Okay, so firstly, if you are looking at a paper 1 exam, your paper 1 exam contains different cognitive levels, different levels of questioning. Now, the mistake learners make is to think that the higher the level, the more difficult it is in physical science. But that's not completely true. The levels are about how your brain processes the information in order to get the answers. So if we are looking at level 1 questions, that is remembering and recalling. That is something I am terribly bad at. If you tell me to memorize a definition, I suck at definitions. So for my brain, that's not easy, but for someone else's brain, that is. Okay. Level 2, there we speak about understanding and comprehension. Anything you need to explain in words. Is it increasing, decreasing? Explain why. Give a reason for your answer. That is level 2 questions, and I have found my matric learners tend to struggle most with this, either because of language barriers. Guys, English is not our friend or all of our friends. You're going to see from time to time my English also goes off, and it's the only language I can speak, but it's still not my friend, okay? So because of that, because we live in this diverse country of ours, my learners tend to struggle with level 2 questions. And that's okay, but if they know they struggle with those, then they can practice them more and they can improve. So it's important that you're mindful of the different types of questions. If you love math, which tends to be the case with most physics learners in grade 12 prefer math, despise physical science, okay? If you are one of those learners, you love level 3 questions because there you have all of your calculations, okay? Most people tend to thrive in this in their paper 1 exam. And then we have the evaluating, creating, synthesis questions, which tend to be the more abstract, difficult ones that take you a little bit outside the syllabus, let you think in uncomfortable ways and so on. But what I need you guys to notice is level 4 questions is only 10%. So unless you're planning on getting a 90%, that's not your problem, okay? Your problem is your level 3 questions, which is 40% of a paper 1 exam, or your level 2 questions, which is 35% of your paper 1 exam. But if your goal is just to pass, which I know some people have that as their goal, right? Then guys, you must know all of your definitions off by heart from your exam guidelines, or if you're an IB learner, then you learn it from your SAGS document. It is not a difficult task to do, to just study definitions. I don't like it. I know you guys don't like it. But it's about 15% of your paper. So you guys need to get those definitions right. You memorize them and then you vomit them onto the page and then you get your 2 marks for your definitions, every single one of them. So please make sure you know your definitions. Okay, now guys, if we are looking at the paper 1 exam, you're going to see the biggest sections is mechanics, 65 out of the 150 marks, and then electricity and magnetism, which is 55 out of the 150 marks. I know a lot of learners don't like electric circuits and electricity in general, but you need to know a little bit of it at minimum because it's a big part of your paper. Okay, you're going to see on the cover page of that summary document, I have listed all of the topics that you need to know for your paper 1 exam and for your paper 2 exam. I've added them up and I see over here there's about 12 topics which can be expanded even further. And if you look at the paper 2 exam, I always say organic chemistry is 3 parts. So in total I have here about 9 different topics that you guys need to study. It's quite a lot, but once you have that, once you know what you need to study, you can break it up into parts. And my suggestion is master topics. When you know a little bit of everything, then you guys mess up big time. Because then we take you guys into an exam that you are seeing for the first time and you have no clue how to apply yourself. Choose a topic, master it, so that at least you gain the confidence in your exam in that topic and you can make sure that you can write the rest of the exam comfortably. Now, on the note of the number of topics you guys need to study for your exam, I just want to show you guys how I studied and how I always advise my learners to study. This is not in your document. I can see some of you are paging through. I'm very sorry. I'll include it next time, so if you guys want to come back next year, I will have it there, okay? But this is what I do. I say, okay, what paper am I writing? I'm writing physics, paper 1, okay. Then I list all of the different topics that I need to study. And look, guys, I know TikTok has a whole lot of quick tips, you know, look at your exam guidelines based on the mark allocation. 15% means 15 minutes on this. It doesn't work for physics. Our brains are different. You study until you understand the work, okay? That's the rule here. So then you decide how much time you're going to spend on each topic. 1 hour, 2 hours, 3 hours, depending on the difficulty. 30 minutes, maybe you know it very well. And when I'm done with that, I print out one of these, which are available for free on the internet. It's just a month planner. Now on this planner, what I've done is I've indicated the start date of the DBE exams, the departmental, the government exams. It's the 30th of October, if I'm not mistaken. And if you look at this, you're going to see in that same week, the Friday of that same week, you guys write math paper 1. The next Monday, you write math paper 2. That Friday, you write physics paper 1. And the following Monday, you write physics paper 2. Okay. But guess what? The department decided they're going to make things interesting. So on the same day as physics paper 1 and paper 2, you're writing business. So to my business learners, I wish you well. But remember, physics is your favorite, so you guys must study your physics, okay? All right. So based on that, it means you guys need to plan exceptionally well. You really, really need to plan well, because I'm telling you guys now that the day before a math exam, you're not going to care about physics, okay? You might be writing something in between, and if you are writing, let's say, life science here, you're not going to care about physics the day before life science. So you guys need to plan very well. So this is what I used to do. I was very mathematical about all of my planning. I would say, when's the start date? Here's my start date, the 30th. How many topics do I have for paper 1? 12 topics. So I counted only Monday to Friday. I left out the weekends. And if you want to spend 1 hour on each topic, it means you need to start studying physics paper 1 on the 12th, so that you can finish studying your physics the day before your English exam. That's what I do. If you want to study all 9 topics for paper 2, you need to start studying on the 17th of October for 1 hour every day, for example. and by the start of your exams, you will have gone through every single topic, okay? So that is what I used to do. Maybe it will work for you, maybe it won't, right? But remember, you guys, because you're going to university, you are still trying and testing to see how your brain works. And you know what? If it doesn't work this time around, but you still get into university, you have another opportunity next year to master your study skills. Okay, so there it is. Another suggestion I have is always start by studying the things you despise the most. For me, when I was in high school, I really didn't like physical science. Physical science and the languages, but physical science was the one subject I didn't like. I love it now. It's my favorite topic, okay? But what I would do is, when I planned to study, I would study 3 different subjects every day. I'd start off with the one I despise. I then study one that I really, really like, because that would become my break. You see, so instead of going to watch TV or being on my phone, my break would be to do something different that I like a little bit more. And when I'm done with that hour studying for me it was life science, I really like life science, I would then go back to physics, or then I would do math or something of that sort. But you always start with the things you despise the most. Always, always, always. Because when you are done with that, you're not going to be so motivated. You're going to be tired. But if now you're going to study the thing that you like, it's going to be okay. If you start with the thing you like and then you must study the thing you despise, you're not going to do it. Okay, so start with the things you dislike. Guys, are there any questions? Okay, let's go on then to the physics. So like I said, today we're looking at physics paper 1. So that is your physical science paper 1. That is your physics section. As I said previously, my goal today is not to actually work through the questions slowly. I've inserted the memos on the screen. You guys have the memos. So I'm just going to point out the things that you guys tend to make mistakes in or with and so on. But then also, every time we go and we mark exam papers, learners tend to decide how they're going to complete the booklet, and that causes problems. Again, this over here is your government paper, so IB learners, I'm very, very sorry. I'll do better next year. Okay, so you can come back next year. But this over here should be very familiar to you guys. This is the instructions page that you find every single time you open up a government exam for physical science. Now, there are some things I want to point out. Number 1 is bullet point number 2. They say, no, not bullet point number 2, bullet point number 3. Guys, when you write your exams at the end of the year, whether it be physical science, mathematics, or anything else, please remember, your teacher who loves you so, so much and adores and appreciates you is not going to be marking your paper. So you need to write your exam in such a way that it makes it easy for the person who will be marking it. Guys, last year I marked over 1,000 papers. Imagine how I felt by the time I was on the 1,000th one. I just wanted to get done. So if you make it difficult for us to mark a paper, it becomes difficult to see and to mark correctly. So please follow instructions. This says start each question on a new page. Please follow this instruction. It makes it easier for us to add up the marks. When you have many questions together on the same sheet of paper, I don't mean an actual physical sheet, but on the same side, it makes it very difficult to add up the marks and to distinguish between the different sections. So please start each question on a new page. Okay, the next thing, over here. Number the answers correctly according to the numbering system. Guys, some of us get very, very anxious when we get into the exams, and because of that, we don't always make best use of the reading time. If you're one of those learners, please spend your reading time focusing on the multiple choice section. Make sure that you use it to analyze multiple choice, and so that when they say go, you can start with the multiple choice immediately. But on this note, what my suggestion is, when you get into the exam, I know there are a lot of learners who skip multiple choice because it overwhelms you, and we have learned multiple choice is not the easiest section. So what you do is you leave it for last. What I want to suggest to you guys is start off by writing down question number 1, write down 1.1. Skip a line because that is what the instructions say. Write 1.2, so on and so forth. Leave it blank. You'll come back to it later. If you run out of time at the end of your exam, when the invigilator says there's 2 minutes left, please make sure you never ever leave multiple choice blank. Never ever. Technically, sort of, you have a 25% chance of getting it right. Most of the time, the answers are C or D. I'm sure you guys have picked that up when you've tried past papers. C and D, they tend to be the most common ones, okay? So go and guess, but never leave multiple choice blank, please, okay? But please start with question number 1, then do question number 2, so on. If you complete a section and then you realize, oops, I made a mistake and there's no space, please indicate to the examiner, say, please see question 2.2 on last page, or please see question 3.4 in book 2, okay? Just so that they know it is somewhere, you didn't just skip or cancel it. And guys, you never cancel, you never scratch out until you've attempted it again, okay? What you guys do is you scratch out because now you're nervous, I did something wrong, then they say time is up. And you haven't attempted it because you ran out of time. You haven't tried to fix it. But guess what? If you didn't cancel that, we could still mark it. So you only cancel when you have corrected it. Then you go back and you cancel. Okay. Then guys, show all formulae and substitutions. You only get a formula mark if you substitute into the formula. So even if you substitute nonsense from the question into the formula, do so, because you will get a formula mark. Please do not skip a question. Write down a formula, attempt the question, so that you can at least get a formula mark. And guys, please don't try to impress us. You copy down formulae exactly as they are on the formula sheet. Don't manipulate them. Don't do anything to them. You copy them down. You plug the numbers into it. And then and only then do you start to manipulate your workings, okay? Formula first, sub directly into it, exactly as it is on the formula sheet. And then and only then do you manipulate. Don't make smart formulae. I know your math is good, but I'm a physics teacher. I don't really worry about that, so don't try to impress me, okay? Then guys, round off your final answer to a minimum of 2 decimal places. This is mostly important for the chemistry because there things are very small and those numbers really count. But in physics as well, you only round off at the end of a question, otherwise your answer is different from the memo. And guess what? When I'm done marking the 1000th paper and yours is 1001, and yours doesn't look like the memo and my eyes do this, I might end up marking it wrong. So please, guys, you do not round off in between. If you need to, if you're feeling lazy, keep 5 decimals or more, but do not round off. You only round off right at the end, okay? This one, give brief motivations discussions. Please, I beg you, please use bullet points. Don't write me essays. Don't write a beautiful long essay. It makes it difficult for us to see the points that you are making, the individual points that you are making, and you also don't realize what you are writing down for marks. So what you do, you end up writing a paragraph where you go in circles about the same thing, and you keep repeating the same thing over and over again. So instead of getting your 3 marks, which is normally the case in this section, paper 1, you get 1 mark. Because you said the same thing over and over and over again. You make bullet points, please, and you answer using bullet points. This is not a language subject, it's physical science. I need to see your bullet points, okay? Then guys, on your formula sheet. Guys, by this time of the year, you must all know your formula sheet. When I was in grade 12, I did not know anything about the photoelectric effect. I don't know at which point in the year, it was a long time ago. But what I did know was what each symbol in the formula represented. So when I got into the exam, I just plugged things in and boop, I got the marks. So make sure that you know your formula sheet. Keep one, there's one at the back of that summary booklet of yours. Fill in what's not there so that you know what is there and how to get what you want from the formulae that are there, okay? On your formula sheet is a table of physical constants that we tend to overlook, and I say so because I did so as well. On this table of constants, guys, in case you forget your gravitational acceleration, there it is, okay? But the things that are also important on this table of constants is the charge on an electron, the mass of an electron, the mass of the Earth, the radius of the Earth. If it is in your table of constants, it means that if I give you a question that requires these values, I don't need to state the values and I don't need to tell you where to find them because they are in your table of constants. So please go over this table of constants. When you practice past papers, have this next to you and use it so that you know where to find exactly what you are looking for. Okay, are there any questions? Okay, if not, we can go on to the first section, Newton's laws. Now, some of you have seen this before because you were with me during the winter school. Today, I'm going to keep it very, very short and sweet. I will not go into any details. Very quickly, you guys are all familiar with weight, also known as the gravitational force. You guys know you can calculate it by saying Fg equals mg. Please note that this g value can be for any planet. It does not have to be on the Earth. On the Earth, your g value is 9.8 meters per second squared, but we can take you to Mars if we want to, or planet X. That's the most common one. We take you to planet X. And then you might need to calculate g. Now, this formula that you're seeing on the board, this one over here, it was a requirement that in grade 11, you had to know how to derive it yourself, which means they do not have to give it on your formula sheet. Okay, it does not have to be there, but you may need to use it. So just very quickly, if you need to find or make this formula up, we know that Fg is equal to mg. That's the first thing we know. But we also know that we can calculate Fg according to Newton's law of universal gravitation by taking the constant times m times the other mass divided by r squared. Okay, so for my math learners, if we are looking at the same object, then we know Fg is equal to Fg. And if the left-hand side of both equations are equal, what does it say about the right-hand sides? They're also equal. There you go. So based on that, we can say mg is equal to gmm over r squared. Now there is a constant that you guys should be able to see is on both sides of the equal sign. What is that number, or not constant, variable, that's on both sides? The small m, which means I can cancel them. And then I find out that g is equal to gm over r squared. If this formula is not given to you, but you need it, you use your other formulae in order to derive it. So there was a question, I can't remember if I took this from the paper that you guys wrote the other day, or if this is from last year's paper, and it says the following. The acceleration due to gravity on the Earth is g. Which one of the following represents the acceleration due to gravity on a planet that has twice the mass and half the radius of the Earth? So I'm going to give you guys 2 minutes to try that yourself, and then we'll see if you're on track. All right, guys, it seems like you guys are done. These questions tend to be common, or these types of questions tend to be common in the electrostatic section as well. So you need to know how to work around them. It's more math than it is physics. So what we know is G is equal to gm over r squared. That is how we're going to calculate the acceleration. So in this question, what I'm going to do is I'm going to say the new gravitational acceleration on the other planet is going to be twice the mass. That means we're going to have g, and in the place of the original mass, I'm going to put down 2m over, at the bottom, we said half the radius, so in the place of the radius, I'm going to put half r, and then this whole thing I'm going to square. Do not forget the square. Our goal is then to get a constant or a coefficient at the front of this over there. So what I'm going to do is I'm going to take the 2 and move it to the front. I'm going to end up with 2gm. At the bottom, according to mathematics, we are allowed to distribute an exponent over a product. So this is going to be half squared multiplied by r squared, not m, sorry, r squared. You guys must please forgive me for my handwriting. It's very difficult to write from where I am. So if we manipulate this, or if we look at the front, we're now just interested in this part. I'm going to work it out on the side. We have 2 over 1 over 4. Mathematics says when you divide by a fraction, we tip and time. So this is 2 times 4. And what is 2 times 4? 8. So we end up with 8 multiplied by gm over r squared, making the new gravitational acceleration 8g. Are there any questions? Okay, you're going to see a lot of these. I see them in almost every single past paper, not necessarily in this section, but all that you do is plug in. If you have something squared, remember to include it in brackets and to distribute, and then you are just looking for the number right at the front. Okay, on to the normal force, guys. I'm not going to speak too much about this, but what I do want to point out to you guys is the normal force is not always equal to the gravitational force. If you have an applied force at an angle upwards, then it's going to make it the gravitational force minus the y component of that force. If you have an object on an incline, then we know that the normal force is equal to Fg perpendicular. So please be very careful. Don't just assume that the normal force is equal to Fg, because in grade 12, in most cases, it will not be. Friction. Now you know there's static friction and you know that there is kinetic friction. There are different formulae that you use for each of these. The first thing I want to remind you guys is that the frictional force opposes the motion of the object. It does not oppose the applied force. Okay, you can be trying to pull something uphill, but because it's so heavy, it keeps moving down. Okay, in that case, the applied force would be up, but because the object is moving down, the friction force will be up as well. I'm going to say it again. Your frictional force is not in the opposite direction to the applied force. It is the force that opposes the motion. So your question is, in which direction is the object moving? And based on that, you decide on where the friction force will be. Okay. Please make sure that you use the correct formulae. If the object's not moving, then you use static friction. If the object is moving, then we start to speak about kinetic friction. Both of these are supplied on your formula sheet. Now, a common question that has come up in recent exams is about values or things that affect the friction force. Guys, friction is dependent on 2 things. And the way you're going to know what it is dependent on is by taking a look at the formula. Okay, according to the formula, we calculate friction by saying the coefficient, whatever it may be, static or kinetic, multiplied by the normal force. Okay, so number 1, friction depends on and is proportional to the normal force. That's the first thing. Number 2, friction depends on the coefficient. Now the question is, what is the coefficient about? Why is it there in the first place? Okay. Yes, I hear someone saying it. The coefficient is about the types of surfaces that are moving across each other. Is it silk on rubber? Is it silk on wood? Is it wood on concrete? Based on the types of surfaces, you will have different values for your coefficient of friction. So what does this mean? It means if I have a rough surface and I draw 2 objects, here's my first object over there. Okay, it needs to be on the surface like that. and then I draw another object like this on the surface. And I tell you both of these objects are made up of exactly the same type of plastic, okay? So, and then I tell you, so the types are the same, and then I tell you that this one, the flatter one, is 2 kilograms. It has a mass of 2 kilograms, and the tall one also has a mass of 2 kilograms, right? Based on this formula, if I have the same applied force acting on these two objects, they will experience exactly the same amount of friction, because friction depends only on the type of surface and the normal force. And we know in this case, since we're on a horizontal surface, the normal force in both cases is going to be equal and opposite to Fg, which are equal in both cases. Friction force is independent of the surface area. This is very, very important. We catch you guys out here every single year. Depends on type of surface and the normal force. It does not depend on how flat or round or whatever the area is. It only depends on these two things. Are there any questions?
Yes.
Yes.
If the coefficient is 0,
Yes.
what does it mean about the surface?
I'd say in that case you wouldn't have any surfaces. As long as we have surfaces rubbing against each other, there has to be a coefficient. Okay? Alright. Then guys, Newton's third law of motion. We like to ask you guys about Newton's third law in the section on Newton's law of universal gravitation. I spoke about this a lot during the the winter school, so I don't want to spend too much. Oh, this is the first law. I'm sorry. Guys, this is what I want to say. If you are looking at the first law of motion, please start off by writing down F net equals 0 newtons. You're going to get a mark for that. And something you guys leave out whenever we ask you guys for the definition is constant velocity. So a body will remain in its state of rest or motion at constant velocity unless a non-zero or net force acts on it. So please make sure you start with that. Newton's second law, I think you guys now all know how to define it, okay? But if you forget, this is all we do. You guys need to create links between the formulae and the definitions. If I divide both sides by mass, I'm going to end up with acceleration is equal to the net force divided by the mass, which tells me that the acceleration is directly proportional to the net force and inversely proportional to the mass, which is exactly what the definition says. So please try to create links between the definition and the formula on your formula sheet. In that case, if you forget, you can find a way to remember it. Now, Newton's third law was the one that I was excited about. If we have a big planet, and I tell you that there's a ball that has been thrown up into the air, and I then ask you how much, or to calculate the gravitational force that this planet exerts on the ball, you will go and calculate it and you will get an F value. Then in the next question I will say to you, compare the force that this ball will exert on the Earth or the planet to the force that the planet exerts on the Earth. And this really baffles your brains because you guys think, or what you guys do is, you confuse Newton's third law with the result of forces. Okay, so guys, imagine I have a huge truck. Here's a huge truck. You guys all see my pretty green truck, okay? Then over here is my little microphone. Now, I'm not very strong, but if I push with my finger against this microphone, it's going to move. If I take exactly the same force and I apply it on this huge truck, which has its handbrake up, same force, and I apply it, is the truck going to move? No, it won't. The force is the same. The microphone will move, but the truck is not moving with the same force because it's this huge object. But if the truck is not moving, does it mean I'm not pushing against the truck? No, I'm still pushing. So don't confuse the force and the concept with the effects of the force. When you throw something up into the sky, like the pen, you find that the pen goes down, and as a result, you guys will tell me the earth is acting on the pen and pulling it down. But what you guys miss is that the pen is also acting on the earth, and it is pulling up on the earth with exactly the same magnitude of force. But why does the earth not move? Because it's my huge truck. It's not going to move with that tiny force on it. So if you have a ball in the sky and a planet pulls down on it, and I ask you about the force that the ball exerts on the planet, they are equal in magnitude but opposite in direction. The fact that the planet does not move does not mean that Newton's third law does not apply. Okay, moving on. The very last one, I'm not going to spend too much time on this. I just want to point out that when it comes to the universal law of gravitation, you guys tend to leave out the word product and you leave out the word square and centers. That is why I highlighted them. Please make sure not to leave them out in your exams. Okay. Now, here we have the very first question. So if you guys open up, this is the first exam. You're going to skip the multiple choice section, and you're going to go straight to question number 2. We have an hour left, guys, so you must be strong, ne? Okay. So grade 12s, like I said, I'm not going to work through these with you. I have the memo on the page. You guys can open up your memo as well so you can see the things that I point out. You will work through this in your own time, and as a matter of fact, some of you have already done so. But I'm just going to point out the mistakes that you guys make so that you never ever make them again. If that gets you an extra 5%, that is a lot of extra marks to get in a physical science exam. Okay. Now, when you get into your exam, the first thing you're going to do, or the second, third, I've given you guys lots of first things to do, is you're going to go to question number 2, 3, 4, which is normally Newton's laws, momentum and impulse, and vertical projectile motion. And you're going to write at the top of each of those pages on the question paper, direction, because these sections deal with vectors. And if you leave out directions, then you leave out your marks and you're not going to get them. But it happens to the strongest learners every single year. You guys become so anxious that you leave direction. So what happens is your calculation is wrong. Or if your calculation is right, when you give your final answer, you forget to include the direction. So please, guys, as soon as you get into your exam, for question 2, 3, 4, which is Newton's laws, vertical projectile motion, impulse, momentum, you're going to indicate at the top vectors or direction or something of that sort. Okay. Now looking at this question, there's a lot of information given. They say crate P of mass this amount is connected to another crate Q of mass 2 kilograms by a light inextensible string. The two crates are placed on a rough horizontal surface. What does that imply? Friction. There you go. So that implies that we have friction, and we're going to indicate it. So some of you write a list, some of you go and you label. But I was very, very surprised when I opened my learner question papers at the end of the exams. Very few learners actually make notes on the question paper. Please make notes. Please highlight. Please label the values. I want to bring you guys back to grade 3. In grade 3, we introduced you guys to word sums. And most of us struggled with word sums. Physics is word sums. So you need to create order. And how are you going to create order? By highlighting, labeling, and listing. Okay, so we're going to highlight and we're going to label. When we see the word rough, we're going to tell ourselves this implies that there is friction. Then they say a constant force F of magnitude 7,5 newtons acting at an angle to the horizontal is applied on crate Q. Now this tells us two things. Number one, when you draw a free body diagram, if they tell you to draw a free body diagram for Q, you are not going to label the force FA. It's not FA. We told you it's force F, so you must use the label F. Guys, sometimes we are funny. Sometimes we find ways to rob you of marks. So please stick to what we tell you. This is force F, so you just use the symbol F. The other thing that this tells you is, as soon as you see that we have a force at an angle, we know that for this crate, the normal force is not going to equal to Fg. And that is important. You make sure that you don't make it equal to Fg. In this case, because we are pulling up on the surface is not pushing into the ground as much as it was initially. And as a result, the normal force will be smaller than the gravitational force. If I push down on the surface, the normal force increases. But when you see a force at an angle, immediately you must know that normal force is not equal to gravitational force. They then give us the acceleration, so we highlight and we say acceleration. They tell us we are working with directions left and right. Sometimes it's east and west, then you stick to that. Sometimes it's north and south, then you stick to it. Sometimes they don't give you direction, and then we say in the original direction or in the opposite direction. But in this case, we are dealing with left and right. Now you see this over here, this information. Those of you that are very anxious learners, you tend to skip it when you get into the exam. And then you try to do calculations and you have no clue what's going on. Make sure that you never ever skip information between a diagram and questions. So if you must highlight, then you highlight grade 12s. If your question paper looks like the rainbow, you make it look like the rainbow as long as you get your marks. Okay, so they say here, grade P experiences a constant frictional force, which they give us, and Q experiences a constant frictional force, which they give us as well. Now guys, I know that these frictional forces are going to be towards the left, but it is not because this force is to the right. Okay, the reason I know, okay, it would be, but the reason I know is because the system is accelerating to the right. So it is moving to the right, and immediately I know we have friction towards the left. What I expect each of you guys to do when you get into your exam is, even if you have a question like question 2.2, which says draw a labeled free body diagram for crate P. Even if they only say draw a diagram for P, you draw it for both. You show this one on your answer booklet, and the diagram for Q you're going to draw on your question paper, so that you can see a free body diagram for both objects. If you don't have a free body diagram for both objects, you are going to lose marks. Okay, now guys, unfortunately, if you make a mistake, so if you have a question like this one, draw a labeled free body diagram, and you make a mistake in that question, and then you go on and you do a calculation based on whatever you drew, you unfortunately don't have consistent accuracy marks or positive marking. So if you mess up here and you mess up in your calculation, you're going to lose those marks in both sections. So you must please take your time to analyze your diagrams and make sure that you draw the correct free body diagrams. Okay, now guys, my government learners, CAPS learners, very important. You are not allowed to, in a case where you have a force at an angle, you are not allowed to show the force and the components on the same diagram. Even if you do it in pencil, you will lose a mark. I'm going to say it again. You may not draw the force and its components on the same diagram because you're going to lose a mark. It is a rule. It's been there for the past 3 or 4 years. Please make sure that if you need to draw the components on the same sketch, you do it on your question paper where the examiner cannot see it, or you draw it on your answer sheet and then you cross it out. Okay. Now moving on, you're going to see in the same question, they say calculate the magnitude of the tension. In this case, we did not have to solve simultaneously. Please be careful and do not assume that because we have a two-body system, we need to solve simultaneously. In this question, what happened was, We had the friction force. We also have the acceleration of the system. And based on that, we are able to calculate the tension in the string. In the next question, they ask for the angle. I'm not going to go through the calculation for that, okay? But using Newton's second law, and as you guys can see, you start off by writing down the second law, please. You would then go about calculating the angle, and you will get your marks. Now, looking at this question, do you have a question? Yes? Yes? Okay, that's a good question. Did everybody hear what he asked? He says, can you see over here in question 2.3.1, you calculated tension. Now in the next question, you need to use tension in order to calculate something else. So the question is, can you use this rounded off answer in order to calculate your next answer? The correct answer is yes. You should, you must. You see, in between you don't round off. But once you have rounded off and you have concluded on your answer, you use that answer in your next question exactly as you've written it down. Okay, if you keep it as it was on your calculator, you might find that it may differ in terms of decimals, which I don't think will penalize you for, but use the rounded off version. Is that okay? All right. Now guys, looking at this question, I know you haven't worked through everything, but I now have a level 2 question that I sucked out of my thumb that I want you guys to try. We have these two bodies, okay? The one has a force on it at an angle. We know that there is friction acting on both bodies, different amounts of friction. My question for you guys is, what will happen to the magnitude of the friction force on Q, right? That is the one that has the force F acting on it. If the angle at which the force is applied is decreased. Write down increases, decreases, or remains the same, and then give a reason for your answer. Please take note of the fact that this is out of 4 marks. I want you guys to try this now, please. All right, grade 12s, all of you have sort of attempted this. You guys are getting tired, and I understand. Only like 30 minutes left. Okay, so we must be strong. Okay, so guys, what happened was we had Q. And if we look at Q, there is a force acting on it at an angle. My question was, how will friction be impacted? So the first thing you guys should have done is you should have realized, in this case, the friction force is my dependent variable. This is a level 2 question in a physics paper. When you answer these questions, you always think independent, dependent, controlled variable. Okay, that's how I want you guys to think from now on. So what is dependent? It is my friction force. What is changing here is the angle. Now, since friction is our dependent force, we're going to go to our formula sheet and we're going to find a formula for friction. We know that friction is equal to the coefficient, whether it be static, kinetic. In this case, it's going to be kinetic friction multiplied by the normal force. Okay. Now we know in this case, Q has not changed. We are still looking at the same body moving across the same floor. So grade 12s, what does that imply about my coefficient? It's constant. So I have now identified my control, my dependent variable, and what is the independent variable? The normal force. So the theta value, the angle, is going to impact the normal force, which will impact our friction. So what I've done here is I've drawn 2 exaggerated versions of this force at an angle. This is my original force with the theta value. And if we go and we draw in the components, this will be the x component, and over here is going to be the y component. If I look at the other one, here is my x component, and over here will be the y component. In this case, I've taken my theta value and I have decreased it. Now, when we have a force at an angle, we know that the friction, the normal force is going to equal to Fg minus the y component of that force at an angle. So look at this. What has happened to the y component of the force when I decrease the angle? It decreased. So this value over there, this value became smaller. So I am now subtracting a smaller number from the gravitational force in order to find the magnitude of the normal force. You have 100 Rand. Originally, the sweets cost 50 Rand. Now the sweets only cost 2 Rand. Are you going to be left with more money or less money? More money, because we're subtracting a smaller number. You're only paying 2 Rand, okay? So that means when the y component becomes smaller, the normal force becomes bigger. And since the normal force becomes bigger and it is directly proportional to the friction force will increase as well. Okay, so what is, or how are we going to write this down? We're going to write down it increases. For writing down that it increases, we're going to get our first mark. Then we are going to say, and I'm going to summarize it, or I'm not going to write it down in full words. We're then going to say when the theta value decreases, the y component of force F is going to decrease as well. Therefore, the normal force is going to increase. For this, you will normally be awarded 1 or 2 marks, okay? Then we go on, and guys, you must then go and state this. This is, if you're a Gauteng learner, this is what I found learners left out all the time. You need to then go and say, since the friction force is directly proportional to the normal force, the friction force will increase as well. So you need to use the words directly proportional and inversely proportional, please. And based on the formula, you need to state this, because in the Gauteng paper, which is included in your pack, by the way, you get 1 mark for making this statement. Okay, you must speak about direct and inverse proportion. Grade 12, there's no such thing as indirect proportion. It doesn't exist. We use the term inverse proportion. If you write down indirect, you're not going to get any marks. Are there any questions, guys? Are we okay? Okay, if there are no questions, let's move on to vertical projectile motion. For some people, this is their best friend. Some people, not so much. It depends. I think it's sort of a geometry thing. Some people thrive on geometry. Some people despise it. I think it just depends on you. What I must say, grade 12s, is, remember at the start when I said to you guys, when you are studying, start with the things that you don't like. Most of the time, we dislike things because we don't understand them. There's a person in your class, a person in your friend group that you don't like as much as the rest because you don't understand why they do the things they do in the way that they do it. Once you understand, you can tolerate things a bit more. So all of these sections of physics that you don't like, once you give them the attention and the love that they need, you're going to find that you actually start to enjoy them. Okay, so vertical projectile motion. Firstly, there are 2 definitions we can ask for, bless you. We can ask for a projectile or we can ask for free fall. In both cases, I need to see the words only gravitational force, only gravitational force. The word only must be there, okay? Where I am at the moment, okay, I'm not moving or anything, but at this point, gravitational force is acting on me. But it is not the only force. There's still the normal force of the ground. So don't just tell me free fall is an object that has the gravitational force acting on it. You have the gravitational force acting on you, but you are neither a projectile nor in free fall, okay? So you must use the word only. If we ask for the term projectile, guys, a projectile is something that has been given an initial velocity. please understand that the initial velocity does not need to be upwards. You can also throw something down, and in that case it is also a projectile. But the key word when we ask for the definition of a projectile that you guys leave out is initial velocity. It's given an initial velocity, and after your hands are no longer making contact with that thing, then the only force acting on it is the gravitational force. The reason why it still continues to move as though if your hands are still pushing on it is because there's been a transfer of energy, and it is the energy that remains, not the force. Your hands, in order to apply a force, since we are not magical, right, or superheroes, need to touch things in order to apply a force. So if it is not touching the thing, then it is not applying the force anymore, okay? It continues to move because you gave it energy. Now, equations of motion. Remember I said when you get into your exam, the first, second, third thing you're going to do somewhere in that list, bless you, you're going to write down direction, 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 or vector, 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 because in this section, big mistake we make is to leave out direction. When we look at the equations of motion, the rule for equations of motion is that you may only use it for one-dimensional motion, which means motion in a straight line. I know in your IB papers, you still can have the object moving horizontally or up and down, so there you need to be flexible. But in your NSC exams, CAPS exams, there it's vertical projectile motion, so it's moving up or down. We tend to show it like this though, right? Like that, like a parabola, so that it makes better sense, okay? But we at grade 12 level do not consider the fact that it might be moving to the left or to the right. But anyway, back to this. What is important here is everything here is a vector except time, okay? That means when you plug in final velocity, initial velocity, acceleration, displacement, you need to take direction into consideration. And if you do not do so, you're going to lose marks. In this past, prelim exam that you guys wrote, there was one question where you could leave out direction and you'd still get the same answer. But we marked based on whether the directions, as you subbed into the formulae, were there or not. So even if your answer was correct, if you did not take direction into consideration, you unfortunately lost your substitution, your final mark, and if there was direction, your direction mark as well. So please, my dear humans, you must remember direction. And remember in this section, direction is it positive, is it negative, based on what you decide. But sometimes, to make our lives easier as markers, we tell you what to do. So please look out for questions where we say, take up as positive. If we say so, you must do so. Or questions where we say, take down as positive. If we say so, you must do so. We're applying concepts, and therefore you must be flexible, okay? Now, if you choose to take up as positive, throughout your question on vertical projectile motion, you must be consistent. It means throughout the question, up is positive. Please don't chop and change in between, otherwise your answers are going to be wrong, especially when you use one answer to go into the next answer. Another mistake you guys make is sometimes you get a negative value as an answer, as an initial velocity, a final velocity, that you must then use in the next question. But because we interpret it, meaning we write it as positive and then we say down, you guys forget to put the negative in. Please remember direction even when you go from one answer into the next question. Okay, please, direction, direction, direction. It is something that the strongest learners tend to miss. Okay, now over here we have your typical vertical projectile motion. I just want to point out a few things. Firstly, at the maximum height, we know that the velocity is 0. And then every year without fail, we ask you guys, what will the acceleration be for 2 marks? 2 marks, that's how we catch you guys out. And my learners do a beautiful calculation and they turn things over and around and they get a beautiful answer that is completely wrong, because all that we are looking for is 9,8 meters per second squared down. That's your 2 marks, 1 mark for the magnitude and unit, 1 mark for the direction. Because even at the maximum height of an object's motion in the air, the Earth is still acting on it. These are field forces. The Earth does not need to jump up and catch the object in order to bring it down, right? So, even when it's at its maximum height and its velocity is 0, the gravitational acceleration is still 9,8 meters per second down. Okay, another big problem. Let's say we throw something up into the air and then it comes back down. Big mistake you guys make is you say that the final velocity is going to be 0. And this is because when you're on the playground playing with a ball or whatever, or you threw your doll in the air or who knows, it fell down and whoops, it stopped moving. Okay. But the reason it stops moving is because there's a short period of time where it can interact with the ground and be brought to a stop as a result of the net force that the ground is exerting on it. To remember this, I want you guys to remember the following. If I am standing on top of this building and you are standing on the side, and I hold a brick above you and I say, can I drop it? You're probably going to say no. Because you know when that brick hits your head, it's going to hit you very hard. Why is it going to hit you very hard? Because its final velocity is not 0. Okay, the final velocity normally is a large number because this thing has had time to accelerate at 9,8 meters per second down. But why will the brick eventually come to a stop? Because your head will stop it and then the ground will stop it and then you will fall over and so on. Okay, but please, final velocity is not going to be 0. Then guys, graphs. I know graphs tend to be a very big problem. You guys must learn and understand the concept, please. Okay, if I have an object and I throw it up into the sky and it comes down past its initial point, I could, for example, draw a position time graph like the one that you are seeing. On your position time graph, the x-axis, where y is 0, is your reference point. It is the point that you take as 0. So in this case, what it means is that we have taken the start to be 0. It goes up, it comes down, and afterwards it has a negative displacement from the 0 point. When you have a position time graph, a turning point on the position time graph literally means a turning point in the motion. The object went up, it turns around, okay, not necessarily turns around, but changes direction and it comes down. You can walk a position time graph and you'll be fine doing so and you'll get your marks. But you cannot walk a velocity time graph. When this graph passes this point, it does not mean it's come to a stop. It simply means it has passed our reference point, the point that we have taken as 0, and it has started to move away from it in the other direction. Now looking at this graph, what is so important is to remember that the gradient of a tangent to this graph will give us velocity. So I can go and I can draw a whole lot of tangents, and what we are seeing on the left hand side is that the gradients of those lines are becoming less and less steep. We have positive lines, positive gradients, but they are becoming less and less steep. That means the object is moving in the positive direction, but it is slowing down. Okay, so if we look at the corresponding velocity time graph, this section over there is, it starts off at a high velocity, we are throwing it up into the air, and what is happening is it is slowing down. I know it looks like it's moving backwards, but that is because you cannot walk a velocity time graph. You analyze it and you look at the numbers. If we start off with a velocity of 10, and it goes to 5, and then to 0, it means that the object is slowing down. It hasn't turned around because all of these velocities are still positive. Then what happens is our gradient becomes 0. A 0 gradient means the velocity is 0. So this point is the same as that point, and it means that the object has changed its direction. A turning point on a position time graph literally means that the object has changed direction. But where it cuts through the time axis on the velocity time graph is where the object has changed its direction on the velocity time graph. So this point over there corresponds with that point over there. What then happens is that the object changes direction. Notice now, okay, this graph looks very, very colorful. Notice now that my gradient starts to lean in the opposite direction. I now have a negative gradient. What does that mean? It means the object has changed direction and its velocity is now negative. Is my gradient becoming steeper or is it becoming more flat? Steeper. See, it starts off flat and it becomes steeper, 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 steeper. So what is happening is my object is speeding up in the negative direction. So look over here, we start at 0, we go to -5 for example, -10 for example, -15. That means the object is speeding up, guys. I know it looks on this graph as though if it is slowing down because we associate negative with the loss of something. But when you look at a velocity time graph, anything on the positive side means in the positive direction. Anything on the negative side means in the negative direction. And if it's moving away from the time axis, it means it's speeding up. If it's moving towards the time axis, like in this case over there, then it is slowing down. These graphs are very important only because if they ask it, then they're about 5 marks in your test. Yes? Mm-hmm. Yes.
So we were going to use where the ball landed on.
As the reference point. Okay. If we change the reference point, so her question is about your reference point, your 0 position. If they instead said in this question, like they did I think in the Gauteng paper, can't remember, but they said you needed to take your reference point as the ground. If they say so, then it means the object starts above the ground. It's not at the ground. It goes up and it ends on the ground. So you would just take it and move it up. That's all that you're going to do. Is that fine? Okay. I hear ma'am, but I don't know where. Yes. Okay, I'll repeat. So sometimes what they do is they will say to you the following. They'll say that they want you to draw a position time graph. But then they will be specific and they will tell you what to take as your reference point. So you see in this case, for this graph that we have, the reference point, the starting point, or the 0 point, the 0 point we have taken as where the ball starts. That is why where the ball starts is at the 0. It's on the time axis. But sometimes instead of saying take the start position as the 0 point, the reference point, they may say take the ground as your reference point. In that case, instead of having a graph that looks like this, you are going to have a graph that starts somewhere above the ground because the ground is the 0 point. It goes further away from the ground and comes back down to the ground where it stops. Okay, so all that is happening is our graph has exactly the same shape, but it has shifted because our 0 point, our reference point, is now the ground. Is that okay? Are there any other questions? Yes?
Say you went to the exam and you didn't practice how to draw the displacement graph, and you know how to draw the velocity time graph. Is it safe to assume that draw it, if the velocity is increasing, then that displacement will decrease.
If the velocity is increasing, then the displacement is going to no.
On the graph.
Not necessarily. So what you are saying is you are asking if you can work from this graph back to that graph. Is that what you're saying?
Yes, ma'am.
Okay, in that case, so you're not going to make use of whether it's increasing or decreasing. So guys, the question is, let's say I give you a velocity time graph. Can you use the velocity time graph to go and draw the position time graph? The answer is yes, you can. But in that case, we say it's the area under the graph that gives the displacement. So you're not looking at how the velocity is changing. You instead calculate the area here. This area is going to give you this part. And then this area over here is going to give you that part. Okay? No, it won't. Okay, to get the shape, we just talk about increase, decrease, and you need to know gradient. The gradient is going to help you to get that shape. Okay, now back to the velocity time graph, guys. The area under the graph is going to give you displacement. The gradient of the velocity time graph is going to give you acceleration, which makes your life easy if you are only writing on vertical projectile motion. Because in this case, since my gradient is negative and constant, and this is vertical projectile motion, I know that I just need to draw a flat horizontal line at, in this case, negative 9,8 for this acceleration time graph. Okay, so velocity time graph, you can use the area to go back to position time graph. You can use the gradient to go to acceleration time graph. Position time graph, you can use the gradient to go from a position time graph to a velocity time graph. These graphs take a lot of practice, and the problem with them starts in grade 10 because we introduce you guys to them in grade 10, and then in grade 12 we quickly rush through them. Okay, but yeah, are there any other questions on this? Okay, if there are no questions, what I want to point out here again is in your exam, so we're looking at question number 3 now. Please, please, please make sure that you indicate to yourself direction. Vectors are important and direction is important. In this question, they say a ball is thrown vertically upwards, implying that it is a projectile because it is thrown from the top of a building of height 25 meters with a velocity of 12 meters per second. On its way down, the ball passes a door which has a height of 1,9 meters, and then it strikes the ground as shown in the diagram below. Okay. Now, since we don't have a lot of time, I'm not going to spend too much time on this, but immediately, since they have not told us which direction to take as positive, you're going to write down to yourself which direction you're going to take as positive. If you are going to take up as positive, immediately you must remember that your acceleration is negative 9,8. This was the biggest mistake that I picked up in the vertical projectile motion section of the paper that you guys wrote recently. You forgot your direction. Remember that the end of one stage of a motion can be the start of the next. So if you calculate the final velocity of one part, it can be the initial velocity of the next part. Please take time symmetry and velocity symmetry into account. If this ball starts at a velocity of 12 meters per second up, we take this as positive, then it means when it passes this point on this side, right over there, the velocity is negative 12 meters per second, okay? When it hits the ground, you guys now know the velocity is not going to be 0, please. Yes? Mm-hmm. If we take, I heard, if we take acceleration as, if we take down as positive, acceleration will be positive. It will never be negative. For this, never. Okay, so guys, in this section on vertical projectile motion, if you choose a certain direction as positive, the direction of your acceleration is always the same. And the reason is because of this. According to Newton's second law of motion, we have that F net equals ma. The net force is always going to be in the same direction as the acceleration and vice versa. When this object has left its position and the hand or whatever has thrown into the air is no longer in contact with it, let's say for example it's here at the top. The net force that is acting on it is a downwards Fg. Even as it moves up, the net force is a downwards Fg. And therefore, even as it moves up or if it goes down, the acceleration is always going to be down. In this section, acceleration is always down. So if you take up as positive, A is negative 9,8. If you take down as positive, A is positive 9,8. You guys must be consistent throughout the question. Are there any other questions? Yes.
In some questions, we know that in vertical projectile motion, whatever the object that we're talking about, it can be dropped.
Mm-hmm.
We still consider it as a projectile because it does not have
No.
a velocity.
Okay, so the question is, if we have an object that is dropped, so let's say I take the microphone, I hold it, and I leave it. In that case, I'm not giving it an initial velocity, so its velocity will be 0. In that case, we just speak of free fall. We don't consider it a projectile, okay? In this case, so if you go back to your definitions, right? Projectile, according to your exam guidelines specifically, is given an initial velocity. Okay, so I know it's vertical projectile motion, and that can cause a whole lot of confusion because we're still in the same topic, but projectile is when we actually give it a velocity, we throw it up or we throw it down. So when you drop it, then it's just an object in free fall. Okay. All right, guys, so looking at this question, they said define free fall. We're all okay with that. If you look at all of the questions, guys, I think in 3.2 there were 13, maybe I might be lying, but about 13 different options in the memo. So there are so many ways in which you can approach these questions. It's impossible for a teacher to go through all of them in the space that we have this year and even in the session that we have. Guys, I always tell my learners I can get you a 30%. The rest is up to you. Okay, and I really mean it. As a teacher, there's only so much we can do. The hard work that you put in after hours, that is what's going to get you the marks that you want. Okay, but in this over here, look here, they said they took upwards as positive. So since they took upwards as positive, the initial velocity of 12 that was given is positive, and the acceleration is negative 9,8. These are things that we look for when we mark. On the right hand side, okay, this is still up as positive, so I'll just skip that. But yeah, please take direction into consideration when you approach these questions. I'm going to skip 3.2.2, I'm going to skip 3.2.3, you guys will go through that. Over here we have a velocity time graph. If you are someone who struggles with these, this evening, if you guys have even a little bit of energy, work through it so that tomorrow you can ask me questions on it, okay? We are unfortunately running out of time, only 12 minutes left, okay? But yeah, so I'm not going to go through it. You guys go through it and you see if you understand, okay? Let us move on. Just quickly, momentum and impulse. I always thought that this was an easy section, but I'm finding that you guys don't agree with me. You guys tend to find vertical projectile motion to be easier. I find this to be the best of the sections, okay? So I think if I can love it, it means you guys can also come to love it at some point in your lives, okay? In this section, what is important is to be able to isolate the different concepts and also then be able to bring it together. So guys, this document that I've given, just by the way, for those of you that are seeing it for the first time, all of the definitions on it I took from your exam guidelines. I'm not saying you don't need your exam guidelines if you have it, but you can learn all of these definitions. I copied them from the exam guidelines, okay? So use it when you study, write on it, color it in, do what you must, okay? But the first thing we say, momentum is the product of an object's mass and velocity. We know that, but what happens every single year? You guys confuse this formula with kinetic energy, and I don't know why. I think the stress becomes too much. I think you guys are going through a lot. And then I see this, P equals mv squared. Please be careful, guys. You have a formula sheet. These mistakes happen to the best of us. You think that would never happen to you, to me, but these things happen. Please be careful. Change in momentum, we know, is the mass, the final minus the initial momentum. If you are required to draw vector diagrams, I'm not going to go through this now. Guys, on the juniortiki.online platform, I created videos on this section where I go into detail about the vectors now, because there's one paper in specific where we actually have, they say draw a vector diagram for this. Please go and watch that so that you won't be caught off guard. I'm not going to spend time on that. Newton's second law of motion in terms of momentum. You need to be able to state it. Please do not confuse it with impulse. Although the concepts link, they are different. We say Newton's second law of motion in terms of momentum says the net or resultant force acting on an object is equal to the rate of change of momentum of the object in the direction of the net force. So here it is. What often happens is we bring into this section questions about airbags, seat belts. That other word I don't actually know how to say, okay, I don't know how to pronounce, so I'm not going to try, but I know what it is. If any of you are from Mpumalanga, you've been on the Leidenburg Road, okay, between Leidenburg and Nelspruit, there's lots of hills and lots of trucks. And what happens is when the trucks go down these very steep hills, sometimes their brakes give in. So as a safety precaution mechanism thingamabob, on the side of the roads are these long beds made of lots of gravel and rocks and so on, so that as the trucks go down, if they lose control, they can actually glide off the road and use these, I'm going to try, arrestor beds to stop themselves. That is basically what they are. And what they do is they make the time of slowing down longer so that the net force can be shorter. If we talk about this law, they might also ask you about a cricket player catching a ball. And what we have seen is when they catch the ball, they do this. Now, it's for many reasons. Firstly, if you just hold your hand there, you're not going to have enough time to catch it. But it also prevents the ball from hitting your hand too hard. So what we are doing is we are increasing the time for the same change in momentum, because we're still bringing it from its initial velocity to zero, whether we catch it like this or we catch it like that. And if we increase the time for the same change in momentum, this is our constant, then the net force, which is inversely proportional to the time, is going to decrease. Whenever they ask you guys about safety precautions, you vomit this onto the page, please, né? For the same change in momentum, okay, over a longer period of time, or let me try again, the same change in momentum over a longer period of time results in a smaller net force and therefore less injury or impact. This is going to get you 3 marks because you have stated dependent, independent, and controlled variable. And it's all just related to this formula over there at the top. Okay. Then on the right-hand side, we have the impulse formula. We say impulse is the product of the net force acting on the object and the time the net force acts on the object. Impulse momentum theorem is very, very, very important, and it's given on your formula sheet. Make sure that you know how to expand both sides so that you can make use of them. Okay. Now, in the exam that some of you wrote recently, there was a question like this. And they said for this question, determine the impulse. And it looks like a difficult question because in a lot of cases it was the first time you guys saw something like that. But it's actually very simple. See, this graph is a graph of net force versus time. Now, on the note of time, every single learner, okay, not every single, there were a few that got it right. Guys, I only have a class of 12 learners, so when I say every single, shame, it's very few, okay. But anyway, a lot of people missed this, okay. Even in the section on, I think, electrostatics, they gave you the force in nanocoulomb, and they gave you the, I think it was field. What else did they give you? I can't, the charge. The charge was in nanocoulomb, and the field was in kilo something or something. Guys, please pay attention to the labels, because this affects your calculation. Okay, it really, really, really does. Milli means the same thing that milli always means. Milli means times 10 to the power of -3 or divide by 1000. It always means the same. Micro always means the same thing. Kilo always means the same thing. In your pack of notes, in your summary notes, in the section on electrostatics, you're going to see over there that I have included all of those conversions. You can use that for any section. Okay, but over here, if you're looking for impulse, and please do not summarize impulse. I think at university level we use the symbol rho to represent impulse. You guys must unfortunately write out the whole word. Nah? We say impulse is net force multiplied by change in time. So if you wanted to find the impulse for this object, all you had to do was find the area under the graph. I'm sorry, I'm going to make a lot of heart skip beats now. In this case, we have a triangle, and we know that a triangle's area can be calculated as half base times perpendicular height. So you actually just had to say 15 times 10 to the -3 multiplied by 64,13 in order to find your answer. But again, what messed you guys up was the milliseconds. Some of you guys had the right idea, but the milli threw you off. So to remember this, in the notes I've included impulse is equal to the area under a net force graph versus time. Highlight that, decorate it, color it in so that you never ever forget it. Okay. Now, the principle of conservation of linear momentum. Guys, there are 3 types of questions we can ask you on it. Normally we are dealing with 2 bodies. They might be separate before and after the collision. So let's say you're playing pool. The one ball hits the other and afterwards they separate again. Then we would use the formula in this form. Sometimes we deal with an explosion. You have a rifle, a gun with a bullet inside of it. In the beginning, they are one thing and their masses are combined and their velocities are the same. But after the explosion, the bullet leaves the rifle and then we have 2 objects moving at different velocities. We would use this form if we are dealing with an explosion. And sometimes we have a collision. I don't know why I said jumping off. I should have said jumping onto a skateboard. That's a mistake that I made. Please change this off to onto. Okay. If you have a person running and jumping onto a skateboard, they become one thing, and in the end, the person and the skateboard would move at the same velocity. Okay. What messes you guys up in the definition is the word isolated system. Don't leave that out, please, or you're going to lose a mark. Make sure you know your sigma, I think I'm saying that right, notation, that you write this down before you perform any calculation on the principle of conservation of momentum. I say so because this is an easier thing to get marks for if you by any chance mess this part up. But you will get marks for either of them. So if you start here, that's okay. You're going to get all of your marks, okay? The thing that is a problem is elastic and inelastic collisions. For some reason, you guys have the idea that if a collision is inelastic, then conservation of linear momentum does not hold. Guys, momentum, your linear momentum is conserved whether the collision is elastic or inelastic. It doesn't matter, it is conserved. Okay, in grade 12, we can take it for a fact that it is conserved. So, if ever we ask you to prove whether a collision is elastic or inelastic, you must follow my steps, I beg you. Number one, you first calculate the sum of the kinetic energies before the collision. After that, in a separate calculation of its own, you then go and you calculate after the collision. You never, ever, ever start by saying EK before is equal to the sum of EK after. Because if this question is out of 5 marks, you will immediately get 4 out of 5. What is happening is you are making an assumption. It's like in geometry. If I say you must prove something and you don't first start off with the construction, you get 0. There are just certain principles that we have to follow, and you cannot make this assumption. Don't even start off with this if you already know it's going to be inelastic. Don't do that. You first do this, then you do that. And then you conclude at the end when you are done. Okay, otherwise you're going to only get 4 out of the 5 marks. So just quickly, I know it's 1:30, just give me 1 more minute. This is a question from the paper that some of you wrote recently. Okay, this is how we would go about it. They said, in which of the following rows does the type of collision match with the total momentum and kinetic energy? Based on what I just said, type of collision, we know if it is an elastic collision, kinetic energy is conserved, meaning it's the same before and the same after. We know if it is inelastic, then kinetic energy is not conserved. A moment ago, I just told you guys, your conservation of linear momentum always holds, and therefore the correct answer here would be B. Okay, I'm sorry for those of you that selected something else, but it is B. Okay, and I've seen this type of question over and over and over again. I'm going to allow you guys to go in a moment. If I can just find something. Okay, there was a question I wanted to include, but it seems it's not here. Let me just show you guys what I meant. See, here is the memo. This is the memo from last year's past paper. Look at the last note. You guys, normally when you're marking, you don't pay attention to the notes that are made. Look at this note. It says, if the candidate starts, this was a question where you had to prove if it's elastic or inelastic collision. If the candidate starts with conservation of kinetic energy, give 4 out of 5 immediately. That means if you start by stating that the two are equal, you immediately lose a mark. So don't start like that. Follow what I've shown you and work around that. Okay. Guys, are there any questions? I'm sure you guys are very tired. I was going to go through the entire syllabus tonight if we had time, but we're going to have to stop here. Okay. So I will see you guys tomorrow for the chemistry. Thank you so much.